Hey everyone, welcome to the video. Today we're going to be looking at how to test whether a series or sequence is an AP, an arithmetic progression, or a GP, a geometric progression. Now let's first of all define what these two things are. So an AP, an arithmetic progression, is where you have a pattern of numbers. You have a series of numbers. For instance, have a look at line A and B here. You have 2, 4, 8, or you have 2, 4, 6, right? They're not both APs, but it's where you have a series of numbers like that. You have a pattern like that, and it's where the pattern is such that to get from one number to the next, you have to add or subtract the same number each time. So you add or subtract the same number each time, okay? So it has to be consistent between every single term, and you have to test that with at least 3 terms. That's why I've got 3 terms to test later on. Okay, what about a GP? A GP is where you have a series of numbers, a set of numbers like 248 or 246. And the set of numbers, if you look at from the left to the right, if you follow the numbers, how they go from one to the next, it's where you are multiplying by the same number each time to get to the next number. So for GPs, it's all about times in by a number to get to the next one. And what you times by has to be the same each time. So this will make more sense when I do the examples. So the official test for an AP. Okay, so if you're presented with a series of numbers, how do you know whether it's an AP? Well, you apply this test and you always write this out first. The test is that you get the third term and then you take away the second term and you make sure that that is the same as the second term minus the first term, because the difference has to be the same. You are measuring the difference, right? D is what you'll see in the formulas for AP, and D means the difference. And the way you measure difference is to subtract. And even though you're subtracting, that still means that when you actually go to do it, you might be adding, okay? So even if numbers are going up by 3, you still want to do this subtraction to see that the difference is 3, okay? So, T3 minus T2, T2 minus T1. We need to make sure that the difference between the third and the second term is the same as the second and the first term to be fully convinced that we have a pattern established. It's not enough to simply look at the first 2 terms, for instance, 2 and 4 here, 2 and 4. Oh, 4 minus 2 is 2. Oh, that's the difference. Well, it has to be consistent, so you have to also look at the third term and the second term. If you don't look at 3 terms in total, it's not sufficient to prove that you have an AP or a GP. Okay, so we need at least 3 terms for both of these tests. For the AP here, we'll apply the test to line A. Let's see if it works. So we're applying this series here, 2, 4, and 8. Let's apply it. So the third term is 8 minus the second term, which is 4. And then let's see if that equals the second term, which is 4, minus the first term, which is 2. Now, 8 minus 4 is 4, and 4 minus 2 is 2. They do not equal each other. So what we do is we put a line through the equal sign like that. We do it diagonally. That means 4 does not equal 2. Therefore, this is not an AP. It is not an AP. What about the second series of numbers that we can see there? 2, 4, and 6. Well, the third term is 6, take away 4, the second term, and then we do 4, take away 2. 6 minus 4 is 2. 4 minus 4 is 2. Perfect. We put a little tick next to it, and we can say, therefore, we have an AP. That means the consequence of that, right? The significance of finding that it's an AP is that if you want to find the sum of the first 100 numbers in this series, right? Not line A, but line B here, 2, 4, 6. Say I want to know what 2, 4, 6, 8, all the way up until 100 would equal if we added all those numbers together. Now that I know it's an AP, I have to apply the relevant formula for the sum of an AP. And you can see that in our other videos. But that's the consequence of finding that it's an AP. It's that you now move into all of the AP formulae, okay? If you want to find any term or you want to find the sum of terms in an AP, you have to go and apply the relevant formulae. Okay, that just is plural for formulas. Okay, you don't apply the GP formulae. Okay, that's the important thing, of course. Now, how do you test for a GP? Okay, so we know that this one is a simple subtraction. Because GP is all about times in by the same number, you actually want to test by doing the opposite. In the same way that we were seeing what number was being added for the AP, right? Or technically subtracted as well. But if you want to find what number is being added, including negative numbers, to find that, you have to subtract the numbers. So in the same way, if you want to find what number is being multiplied between terms, you have to divide between terms to see what that multiple is. So let's test, and I'll show you the test actually first. It is T3 divided by T2. Again, we're testing for multiplication, therefore we use division to see what it is. T3 over T2 must be equal to T2 over T1. T3 over T2 must be equal to T2 over T1 because we need to know that there is the same number being multiplied between each. Okay, so T3 over T2, let's apply it to line A. Okay, T3 is 8 divided by 4 equals 4, which is T2 over 2. Let's simplify this. 8 over 4 is 2. 4 over 4 is 2. Voila, we have the left side equaling the right side. Therefore, we have a GP. Fantastic. So, whereas line A didn't work for the AP because it was 4 to 2, when we do this division method, which is the GP test, it actually worked. Therefore, we have a GP, and if you want to go and find another term belonging to this particular sequence, maybe you want to find the 50th term down the line, or you want to find the sum of the first 50 terms, you use the formulas or the formulae that are associated with a GP. You don't use the AP formulae. So that's the consequence of it. Again, look at our other videos to see what they are and how to apply them. Okay, but this right here is the test. And of course, for AP, we had this as the test. You always start the problems with those formulae and then prove them. Okay, so you can also see in line B here, if we were to apply line B, 6 divided by 4 equals 4 divided by 2. Again, it doesn't mean it does equal it. We're just testing whether it equals it. 6 over 4 equals 4 over 2. Well, 6 over 4 simplifies to 3 over 2, which is 1.5, but I'll keep it in fraction form because it's easier, equals 4 over 2, which is 2. Well, 3 over 2, which is 1.5, does not equal 2. Therefore, not a GP. Now, don't get this confused. Just because it's not a GP does not automatically mean that it's an AP. You have to separately apply the AP test. You could have a series or sequence that is neither a GP nor an AP. So just because it's not a GP doesn't mean it's an AP. Okay, so they are the two tests that you apply when assessing whether a series or sequence is an AP or a GP. Remember, the importance of this is that it will then tell you which formulas to apply when you want to find the sum of a series or you want to find a particular term in the series. Okay, so this is always the starting point. Always start with the formulae. Hope that helped, guys. Like and subscribe if it did. See you in the next video.